So let us take a look at our very last approach to do the probing, which is what we call a double hashing. So what does double hashing mean? It indicates that you have two hash functions. You have a first hash function and a second hash function. The first hash function gives you the home position, and the second hash function gives you the way to look for the next available location. What this trying to do is that unlike linear probing and quadratic probing, because the way they look into the next location is fixed. So whatever elements hitting the same home position, they will follow the same pattern to look for the next available location. What the double hashing trying to do is that even though you have the same home position, but the way you try to look for the next available location, every element will have different methods because there's a second hash function to do that. Let's take a look of the description a little bit more closely. So as I mentioned, double hash function use two hash functions. You will have the h1 to help you finding the home position, and then when I is not equal to 0, h2, the second hash function will kick in, try to calculate the value, and then multiply with how many i's that you have tried to find the next locations that you would want to do the probe. So quadratic probing solves the primary cluster problem, as I mentioned, but it has the secondary clustering problem in which elements that hash to the same home position have the same alternative cells. So in our linear as well as the quadratic probing, once you have the element hitting the same home position, they will follow the same pattern to find the next location. So if you have many elements that hitting the same home position, you will end up with all the elements need to follow the same path, and it will slow down the operation. And that's why we call this going to be a secondary cluster, and that might reduce the performance. And therefore, double hashing function is a hash techniques that do not suffer from the secondary cluster. So by using a second hash function to apply on the values, and it will generate different results for every single item that hits on the same home position. Let's take a look of this using an example. So now, saying that we have two hash functions, the first hash function is the one to help you find the home position. It is going to use the value mod 7. The second one is going to use the value mod 4 to identify how many spaces away from the home position that you need to try. And therefore, you can see that in the double hash function, when we have ki equals to h of k, finding the home position, plus I, that's how many times that you have tried, multiply the second hash function value that gives you. And let's start with the very first example. Store 7. So when h of k, which is 7, 0, that means it's the first time of your try, it will equals to the hash function 1 k mod 7, which give you the value of 0, indicating 0 is your home position. I is 0, so hash function 2 does not have any effects at this moment, and therefore we find the home position equal to 0, we will be able to put 7 in here with only one time of probing. Now let's take a look of the next operation, store 14. Obviously 14, after the first hash function, you will find the home position of 0, so it will need to change I equals to 1 and then use the second hash function to help. 14 in the second hash function mod 4 will equals to 2. That indicating you will search two positions from your home position as your next try, and you can see that indicating we find the available location. So you can see that when we change 14 1, we will have our second hash function be useful and then make us finding the location of 2, and therefore we use two probes to find store 14 into the right position. Next, store 21. You can see that 21 is going to, after the hash function, will map into the home position of 0 again. And then by doing so, you will finding out it is not available and you need to change your I to 1. So we will be able to use the second hash function. 21 mod 4 equals to 1. That indicating you will search one position away from the home position every time you have failed probing. And therefore, you can see that when I is 0, it gives you the home position. When I equals to 1, you will multiply whatever hash function 2 gives you, indicating that you want to search for this item. You need to search one item away from it so that you will get a value of 1. Saying that, you can see if the 7, store 7 is happening, or say that home position of 0 is occupied, you can see that when 7 is happening, of the second hash function, 7 mod 4 equal to 3, that would let you know that every time if 7 has failed its probe, 3 spaces away from the home position is what you need to try. And therefore, you can see, although 7, 14, and 21 all have the same home position, but if their home position is not available, they would need to search different paths. And that is what we want to see, the properties we can gain by using double hash function. Let's see that when we try to store the value of 29, we feed in the equation. You will see that 29 mod 7 get the value of 1. Index 1 is the first try. When it is not available, you will change I to 1. And because 29 mod 4 equals to 1, it indicating one space away is what you need to try for the value of 29. And you will try that one more time to find the index of 3 for available location. And that's why you will have 3 probings over here. Finally, when we try to delete the value of 35, it will give you the same home position 0 with all other elements 7, 14, and 21. When that's happening, we need to use the second hash function to help us find the next location for the probe. And therefore, when we change I to 1, you will use the second hash function, finding out that 35 mod 4 equals to 3, and therefore 3 spaces is what you need to try. In this case, it is occupied, so I will change to the value of 2 to multiply of 3 spaces, indicating 6 space away from the home position. That's why you'll be able to look into the index of 6. Realizing that, okay, this is a null value, so if we have 35, it's supposed to be here. Obviously, we don't have 35, so error message need to show up indicating that there is no 35 available for the operation. So this is the idea of the double hash functions.